Welcome viewers to part 8 of the TitanBot series. In this episode we need to build some integration hardware. We're going to be building a switch adapter housing, a PCB clearance spacer, we need a gearbox bracket shim, and we need an XT60 retention cradle. So let's get started on these parts. Begin by creating a new body and create a sketch and attach that sketch to the XY plane. We'll start with the PCB clearance spacer. This one is a simple shim that we're going to put underneath the PCBs on the Robotics deck. Create one circle that is coincident with the origin, and we are going to set the diameter of this circle to 3.2 millimeters. And we're going to create a second circle around it, also coincident with the origin. We'll set this one to a diameter of 6 millimeters. That's all we need to do for this PCB clearance spacer. So we're going to close out of the Sketcher workbench, and we're going to pad this shape out to 2.5 millimeters. We have 4 PCBs that we're mounting on the Robotics deck, so we need a total of 8 clearance spacers. Alright, so I'm going to hide that for right now, and we're going to move on to the gearbox bracket shim. So let's create another body, and we need to create a sketch for this body. Again, attach it to the XY plane, and this one is going to go underneath the metal mounting brackets that the gearboxes are attached to. We're going to make it symmetric with respect to the x-axis, and we're going to make it symmetric with respect to the y-axis. We're going to set the length of this shim to 15 millimeters, and we're going to set the height of the shim to 5 millimeters, or I guess the width. And now we're going to add the 2 holes in the center of this shim. This is where the 3 millimeter to the mobility base. We're going to make these 2 mounting holes symmetric with respect to the y-axis. We're going to set them to an equal diameter, and that diameter is going to be 3 millimeters. And we're going to separate these 2 holes by a distance of 8 millimeters. And now that our shim is fully constrained, we can close out of the Sketcher workbench, and we're going to pad this shim out to 1 millimeter. Alright, so the next piece of integration hardware that we need to build is the switch adapter housing. This one is going to hold the switch inside the wire conduit of the Robotics deck. So we're going to begin by creating a new body and a new sketch. We'll attach that to the XY plane. And because the conduit inside the trunk of the Robotics deck is oblong or slot shaped, we're going to begin actually by creating the profile of the switch. So we're going to grab the polyline tool, and we're going to rough out that switch profile first. So it's going to look a little bit like this. We will manage our horizontal and vertical constraints on this part here in just a minute. Once we have this roughed out, okay, so here we are. So now we will make sure that our horizontal and vertical constraints are in place. It looks like everything that needs to be corrected. There we go. All right. Now we're going to add some symmetry constraints here. So let's create point of symmetry here around the y-axis. We'll do the same. Well, we'll leave the bottom ones there. Now we'll do those as well. So we'll do symmetry constraints around the bottom, and we will produce a symmetry constraint with respect to the x-axis here. All right, and that very neatly constrains this shape symmetrically. We need to set an equality constraint top and bottom here, so let's do that. All right, so now the shape is symmetric around the origin. Let's set some dimensional constraints now, though. Oh, we'll set these two portions of the shape equal as well. All right, now it is truly symmetric. Okay, so let's grab the dimension tool. We're going to begin by setting the constraints on the outermost part of our shape here. So we'll set this to 15.5 millimeters, and then we will constrain the inner part of this shape to 13.5 millimeters. Now we're going to constrain the overall width of this profile to 9 millimeters, and we need to set the height of these standoff portions here. So first of all, we'll constrain the width of these to 4 millimeters. There we go. So okay, so the internal profile of the switch that we're using is now fully constrained. So now we're going to add the slot shape around this this profile. So we're going to grab the slot tool, and we're going to constrain the slot to the y-axis, make it coincident with the y-axis. And we're going to set the radius on this part. Looks like we have an over constraint here. And just cancel this. I'm going to drag out that. That'll clear the over constraint. So let's try that again. So we'll set the radius on that part to 9 millimeters, and we'll make this slot so that it is symmetric with respect to the x-axis. And now we're going to set the distance between the 2 points of our slot. We will set that to 7.5 millimeters. Okay, and so even though this looks somewhat complicated, or rather the constraints make this look somewhat messy, our shape is fully constrained, and we can close out of this, and we're going to pad this shape to 2 millimeters. All right, and now we're going to add a column on the top of this. So we're going to click on the top face and create a sketch. And we need to make sure this profile extends all the way through. So what we're going to do is we're going to reference these portions of our inside shape, and we will use the polyline tool, and we will trace this internal profile that we created. All right. And this means that when we pad out this shape, the profile will continue up the column that we've created. All right, click to clear our tool. We are going to reference the arcs on the top and bottom of our slot, and that will give us the center, the two centers of our slot. And now we're going to create a new slot coincident with these two previous centers. And sometimes the constraints don't actually connect, so what we're going to do is we're just going to make sure that these 2 points are coincident, and we'll do the same thing for these 2 points below, make sure that they're coincident. And now we can set the radius on the slot that we just created, set that to 6.35. And now that we've done that, our shape is fully constrained. This is our column. We're going to close out of this, and we're going to pad this out to 20 millimeters. And the last thing that we're going to do is we're going to add a retaining hole right here. We're going to secure this adapter housing to the inside of the wiring conduit of the Variances trunk using a screw. So we need that screw hole. So we're going to click on that face. We're going to click on create sketch, and we need to be able to see that channel that we've created. So we'll click on this tool here so that we can view that channel. And we're going to use the external geometry reference tool to reference the length of that channel. And we're going to create a hole, a circle that's coincident with the y-axis. We're going to set it so that it is that its diameter is 2.8 millimeters. It's the minor diameter of the PT screw that we're using. And we're going to use the end of that geometry reference line, and we're going to set this to an offset distance of 15 millimeters. Okay, so now that that's fully constrained, we can close out of this and we can pocket this. All right, so that screw hole went all the way through, and so our switch adapter housing is done, and we can move on to the final part that we're building in this video, and that is the XT60 retention cradle. So we're going to create a new body and a new sketch. We'll attach that to the XY plane, and with this one begins as a rectangle. Again, this one is going to be symmetric with respect to the X and the Y axis. And now we're going to constrain its length to 58 millimeters. And we're going to constrain its width to 12.5 millimeters. Now we're going to add 2 mounting holes in the center. These will be symmetric with respect to the y-axis. And we will constrain the diameter, as always, to 2.8 millimeters. I didn't set those equal to each other. There we go. And we're going to separate them by a distance of 34 millimeters. And so now the base of this retention cradle is fully constrained. We can close out of this, and we are going to pad this shape out to 3 millimeters. We're going to add a feature to the top of this base that we've created. We're going to use the geometry reference tool, bring in the 2 edges of our shape, and then we're going to use the polyline tool, and we are going to trace the outside 3 edges here, and then we're just creating a retaining wall that will pull that XT60 clip in close to the side of the TitanBot. So this cradle has this basic shape. We've got all of our horizontal and vertical constraints in place. We're going to make these edges symmetric with respect to the y-axis. We're going to make the walls of this cradle 2 millimeters thick, both on the edge as well as the top with respect to our current view. So set that to 2 millimeters. All right, so we've set the overall shape of those walls, and we're going to pad that out now to 20 millimeters. We're going to add a chamfer. This will just make it easier to clear the wire that runs along the length of the robot. So grab that, grab the chamfer, and we'll set that to 10.5 millimeters. And lastly, we're just going to round off the corners of this just to make sure that we have clearance for the mecanum wheels that are right next close to it. So we're going to fillet those, and we'll give that a fillet of 3 millimeters. Okay, so there we are. That's the XT60 retention cradle. XT60 is the connector type, and that's it for these integration hardware components.